Pushpa ma'am?
Yes.
Ma'am, shall we start ma'am or shall we wait ma'am?
I
think there are 141 participants ma'am.
Yes, we can. Sir is not there, no? Still do Dean sir.
Vishnu Bhatt sir and Dean sir.
Vishnu Bhatt sir is there?
Yes, ma'am, he is there ma'am.
Dean sir has not yet joined. I just called him. Yes. Sajeeth. Sibi.
Yes ma'am, yes ma'am.
You have muted Dean sir. He has joined 15 minutes back. That's what he is telling.
Yes ma'am.
He's listening to us. He said.
Ma'am, his name has not been displayed.
Huh?
Yes. Yes ma'am, yes ma'am. Ma'am, his muting option has been locked, ma'am. I have requested sir to get unmute.
Sibi.
Yes, ma'am.
It is Dr. P.F. Kotur.
Yes, ma'am. I could find sir's name, ma'am, but I'm unable to mute him. It's given locked option for muting, ma'am.
Sibi, you have muted him.
Yes, ma'am.
You have muted everyone.
No, ma'am.
Able to hear me now?
Yes, ma'am. Yes, sir. Yes, sir. Yes, sir. You're audible now, sir.
He is there.
Dean has not joined the Dean, and you mute me and you expect me to talk, is it?
Madam must have
Good afternoon, sir.
Good afternoon, ma'am. Good afternoon, sir. Dean, sir. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Good afternoon, ma'am. Good afternoon, Sajeeth, sir. Welcome,
Good afternoon,
welcome.
sir.
Thanks for
Good afternoon,
your.
Manivandan, sir.
Good afternoon, ma'am. Good afternoon, ma'am.
Good afternoon to everybody.
Good afternoon, Krishna madam. This is Lakshmi Narayan from AVIT. AVIT IIC.
Anyone from AVIT has joined?
Yes, madam.
Madam, this is Lakshmi Narayan.
Lakshmi
AVIT
Narayan.
IIC.
Okay.
AVIT
And your
IIC.
students?
They are joining. Already some have joined.
Okay.
Yes, madam. Many people on the line.
Okay.
Dr. Bhatt, can we start?
Yes, sir. I think we are delayed by 5 minutes.
Yeah, start. Professor Mateen, everybody is here.
Yes, sir. Shall we start, ma'am?
Yeah, please.
So, a very good afternoon to one and all. Extending warm welcome to all present in this forum. I would like to present the stage now to our beloved students to take over. So, Ms. Pragati, second year MBBS student, would be the student host for you all today. Thank you.
Yes, sir. Can I start, sir?
Yes, Pragati.
As stated by Albert Einstein, the true sign of intelligence is not knowledge but imagination. With this quote, I, Pragati Amruta, second year MBBS, would like to extend a very good and warm afternoon to one and all. I welcome you all to today's IEC program to talk on the topic Innovative Teaching Learning Tools on Virtual Platform. Before we dive in, I request all the participants to mute their mics for a smooth functioning of the event. Any concerns and queries can be addressed in the chat box and will be answered shortly. The meeting is recorded for further academic purposes. Let's begin the event with a prayer song by Ms. Simpy, third year MBBS. Over to you, Ms. Simpy.
हमें देन दाता मन का विश्वास कमजोर होना हम चले नेक रास्ते पे हमसे भूल कर भी कोई भूल होना इतनी शक्ति हमें देना दाता मन का विश्वास कमजोर होना हम चले नेक रास्ते पे हमसे भूल कर भी कोई भूल होना इतनी शक्ति हमें देना दाता दूर अज्ञान के हो अंधेरे तू हमें ज्ञान की रोशनी दे हर बुराई से बचते रहे हम जितनी भी दे भली जिंदगी दे बैर होना किसी का किसी से भावना मन में बदले की होना हम चले नेक रास्ते पे हमसे भूल कर भी कोई भूल होना इतनी शक्ति हमें देना दाता मन का विश्वास कमजोर होना हम चले नेक रास्ते पे हमसे भूल कर भी कोई भूल होना
Thank you, Ms. Simpy. I now call upon Mr. Saurutava Nandi, second year MBBS, for delivering the welcome address. Over to you, Mr. Saurutava Nandi.
Thank you, Ms. Pragati. So good morning here. It is such an honor for me to deliver the welcome today on behalf of management team IIC. It's a pleasure for me to welcome our honorable guest speaker for today, Mr.Sajeeth Kumar, sir, founder and CEO of ReynLab Technologies. Sir himself being an innovator, will be a great enthusiastic motivator to all of us. Thank you for accepting this. G. Selva sir, principal of ReynLab University, and Professor L. Prabhu sir, vice principal of this institution. We are happy to have you with us, sir, and other few. I extend my warm welcome to our dedicated honorable dean, Dr. P.F. Kothur sir, who has been a guiding light of IIC. Without his guidance and support, this journey wouldn't have reached this point. I cordially welcome you, sir. It's an honor to welcome our honorable Director of Medical Research, Dr. Vishnu Bhatt sir, the President of our Council, institution. I extend a warm welcome to our enthusiastic and dedicated Dr. V. N. Mahalakshmi ma'am, Dean HB, who always renders her laudable service to our great institution in the right path. I welcome you, ma'am. It's an honor to welcome our medical superintendent in charge, Dr. Deepa ma'am, who is now a frontline leader to COVID warriors. I welcome you, ma'am. It's an honor to welcome our dynamic Vice Principal, Dr. Rajan sir, and Vice Principal Student Affairs, Dr. Arunachalam sir. Their immaculate job is commendable. I welcome you both, sir. It's a delight to welcome Dr. Pushpa Kotul ma'am, Commissioner of IIC and the backbone of our council. Her is indomitable for our institution to us in a proper way. I welcome you, ma'am. I would like to welcome all our respected HOIs, HODs, professors, faculty members, PGs, and once again, I welcome you all from the core of
Thank you, Mr. Sauritavanandi. I would request our respected Dean, sir, Dr. P.F. Kotur, sir, to please address us. Over to you, sir.
Yeah, thank you very much. I'm an ardent believer of a saying, well begun is half done. Since the inception of the Institutional Innovation Cell on 22nd June, under the able leadership of Dr. Vishnu Bhatt, and the team led by Dr. Pushpa Kotur, there has been no looking back. There is a series of activities have happened. Dr. Manivannan, who is the backbone for this, Manivannan, who is the director of research in VMRF, he is the director of industry and academic relation in VMRF, and it was of course inaugurated by our director Satyamurthy and Dr. Nagappan. Since then, there have been continuous activities, and I have learned that the IIC has got a continuous calendar of events in the time to come. One really a beauty or innovative thing is, as mandated, this activity is an activity of the student, by the student, and for the students. I must compliment and congratulate all our students for organizing these series of programs. I have a sigh of satisfaction for this. And today's speaker, Dr. Sajeeth Kumar, who is the founder and CEO of ReynLab, and his topic is innovative teaching and learning tools on the virtual platform. Ever since the COVID pandemic struck to us, it has had a lot of unprecedented changes in the world, including the educational sector. And many educational institutions had to close, and the students and the teachers have to adapt themselves to the new requirement, new norm. There is no other way. Necessities of the mother of the invention. It was the students, they're young, they get adjusted, adopted very fast. Yes, but the teachers, especially the senior teachers, had to struggle to provide quality education, to see that their students' career is not lost. And the teachers, especially senior teachers, have to understand the various aspects of technology, which will be quite a little difficult for them. But anyway, now looking back at these 17, 18 months of this COVID, everybody has done very well. All teachers have done, students have done well. And of course, one of the main disadvantage of these using the virtual platform for these teaching learning sessions is you will not know whether the learning is happening, what level of learning is happening, what level of the student is able to understand, is he effective or not, unlike in a physical learning. So here comes the role of the technology, which will facilitate the teacher to assess whether the learning is happening to the expected level, those kind of things are there or not. And of course, the technology also helps to assess the students. Many of our teachers are using technologies to do the assessment, internal assessments, and even the technology was used to conduct the university examinations. So I can say that the transformation during this 1.5 years of COVID pandemic is really an accelerated manner. Much is to be appreciated. Everybody must be complimented. apart from doing the teaching and learning on the part of the teacher and the students, the teacher has additional responsibility of providing or preparing the digital format of the teaching materials. So it requires a lot of efforts on the part of the teachers, and the online teaching has to go in a hassle-free, seamless way. For that, the teacher has to have a very understanding of the virtual platform. You have to have a very much understanding of the technology, so that many of times we have seen, even in experts, many times, because technology or communication many times will not be in our hands. In spite of being prepared so much, in spite of being so much, we continue to have some hassles or difficulties or obstacles. Sometimes getting somebody disconnected, then again coming back. These kind of things happen. And every one of this interruption or has been a lesson for us, and we learn from that. So certainly, this is some thoughts which come to my mind, which I think are appropriate. If you Google out many tips will be there, how to make the effective virtual platform, effective teaching tips, learning tips, those kind of things are there. We all have gone through that, and certainly, and I was just going through the website of this ReynLab as well. There are learned people who are facilitating the technocrats and the persons who are involved in emotional intelligence, the artificial intelligence, all the things is amalgamation of all these experts, and they are trying to offer. So let's see what Mr. Sajeeth Kumar has got for us for the medical fraternity. Now, one thing is whether be it engineering fraternity or a medical fraternity, teaching principles are the same. What applies there, what fundamental principles are there, it can certainly be transferred. And now, it's all interprofessional education, interdisciplinary education. So this adaptation, what is good in their engineering, you can adopt it here. What is good in medicine, it will be adopted there. These kind of things have been happening. Thank you very much for sharing my thoughts. And I congratulate all the students who are nearing 250 now, for their enthusiasm. And try to extract as much as possible from today's speaker, Mr. Sajeeth Kumar. With these few words, I welcome all of you. I welcome especially the resource persons, the faculty of AVIT, and the students of AVIT, on behalf of myself, on behalf of university, and on behalf of our management. Thank you very much. Thank you once again very much for all of you. Yes.
Thank you for your kind words, sir. Now over to Ms. Malavika Krishna, second year MBBS, to introduce our honorable speaker, Mr. Sajeeth Kumar, sir, founder and CEO, ReynLab. Over to you, Ms. Malavika.
Thank you, Ms. Prakati. I'm honored that I have been asked to introduce today's speaker, Mr. Sajeeth Kumar, the founder and CEO of ReynLab Technologies, which is an edtech platform for delivering virtual labs and immersive content on mobile devices. His domain expertise is in automobile research and development. He is an expert generalist, a data scientist, a front-end developer, an instructional designer who has proved his expertise in automotive convergence technology and is also an adjunct faculty. He did his mechanical engineering from PSG College of Technology, Coimbatore. He has his expertise on working with programming languages like MATLAB and Simulink, R and Python for automotive and ML applications. Front-end developing using HTML5, CSS, and designing using Illustrator, Animate, and Premiere Pro. He is also working with Pilani as an adjunct faculty, instructional designer, and also is a subject matter expert for automotive engineering and automotive electronic master's program. He also framed syllabus and taught mechatronics, control system, electric vehicles, and advanced driver assistance system. He has his expertise on system modeling, simulation, and analysis with one-dimensional modeling packages. Happy to have you, sir.
Thank you. So thanks a lot for the wonderful introduction. So let me just screen and let's just start presentation. Okay, hope it is visible. Yes, it is. Okay, so before I start, good afternoon, one and all, and my heart thanks and regards for the management for having me here today. Though typically I do not sound like someone who would be invited to talk at the medical universities. I can promise you this: there's going to be a lot of lot of areas where you would find it actually very interesting. The areas what we are currently working on, the same kind of an applications which might be very relevant in the medical domain as well. So once again, thanks for having me here. Good afternoon, and I'm going to be talking to you today about the innovative teaching and learning tools, right? And I'm going to be talking about it from the new normal era. So which means unless I talk a little bit about what this new normal is, it might not kind of like gel in well with whatever I'm going to introduce with respect to the teaching and learning tools. So pardon me if I do digress a bit, but I feel that this is the best way for me to introduce why exactly we are doing what we are doing, and why is it that you should probably be looking at adapting these technologies. So technologies could be either for learning, or it could be for teaching, or as you would see, it could also be technologies which could actually make a whole new career for you, right? So my agenda is going to be at 3-4 different parts. So the first one, I'm going to be talking about what exactly is the new normal, and I'm going to be talking about from a technology perspective. I'm going to also be talking about what we call as the 21st century skill sets. So this is something which is domain agnostic, does not necessarily apply only to engineers. It should apply to any professionals, right, moving into the 21st century. And also about what are the new age tools that we have at our disposal and what you should be using to leverage this, right? So this is what I'm going to be talking about. I would also be demonstrating a couple of virtual tools as well, but I'll just put it towards sometime down the line so that you know I'm able to catch your attention and just move on with it, right? So now the new normal. This is something which you have been hearing for the last 1 year, and there's also a word which probably like sets you off. So if you are anyone like a normal person, then whenever someone says this is the new normal, you learn to live with this, then this probably like is something which is very irritating for all of us. As any change should be, it is very much accepted that if you feel threatened, if you feel upset about what we think of the new normal. But for defending this new normal from my perspective, I'm going to present it from why exactly this new normal is just something which was already in the works, right? So whatever we are thinking, whatever we are doing as new normal, leave aside the pandemic related things, but if you look at things how they've been like moving around, this is something which started, I would say, sometime in the late 1980s, 1990s, right? So we started over there, and it's just been a progression of events, and at least as per what I believe, COVID, the pandemic, it just accelerated what was eventually bound to happen. So please, let me just like take you through what exactly I mean by what changed, right? Or rather, what actually like started pushing the paradigm shift in the way that we are learning, we are going to be working, we are going to be interacting with people. What was it that actually pushed us towards this? So whatever we talk about today, when we say that artificial intelligence is here, we have a lot of new technologies. These are not things which started in the last decade even. This is something which started almost 30 years back. And if you see, they started as laboratory experiments. People were using genetic algorithms, convolutional neural networks, and advanced algorithms like that for carrying out some kind of a laboratory experiments. And in most cases, it was all on genome sequencing, deciphering your DNA strands, doing some laboratory experiments and things like that. So it was basically POCs, proof of concepts. And come 2010s, right, the 21st century, what essentially changed was we saw a leap in computing power. We also saw the introduction of a new type of computing power called as cloud systems. So until then, you should have access to a supercomputer to basically try out genetic networks, neural networks, and things like that. But with the advent of cloud, it became accessible for a common person to basically like start using this. So people started developing frameworks, right? So framework is basically it's like a packaged computing process, right? So you don't develop anything from scratch. Say you are a research scientist, you're a medical scientist, you just pick up this framework, adapt it to your needs, it'll start working. So it's basically you could, I mean, if you are not from the technical background, you could think of a framework as maybe something like maybe you buying a mobile phone, right? You buy a mobile phone, you just put your SIM card in it, you start using it, so everything else is already there. So a framework is something similar for developing code, right? So it became easy for people to start developing code. And then the major breakthrough, right? The major breakthrough, if you ask me, it came in 2014. So 2012 to 2014 is when this artificial intelligence entity, I call it as an entity, called as IBM Watson, right? So this particular algorithm, this particular artificial intelligence, for the first time, it won a Jeopardy game, right? Something which machines were thought they were not possible to do, but this basically started winning Jeopardy games. And not only that, but IBM had its eyes set on a whole lot more of things. So they got into technical partnerships with various hospitals. They landed an order with the U.S. government, the Pentagon, and the U.S. government to digitize medical records of all these serving, servicemen and things like that. So basically, what happened is IBM got its hands on quite a lot of medical records. They were also able to develop what we call as natural language processing, which is basically a computer can read text and it can understand things from it, right? So that's called as NLP, natural language processing. So with this technologies, with this advancements, IBM Watson, it came out with what we call as the clinical decision support system. So what exactly is the clinical decision support system? A lot of you might know. For those of you who don't know, then let me try to put it this way. So over the years, our esteemed doctors, how they have become so good at their profession is because of the experience and the expertise they have gathered, right? They have worked on a lot of different cases. They have read a lot of journals. They have gone in for certifications, and therein lies their expertise and their experience. Now, this IBM Watson, what it is basically doing is it doesn't have that experience or expertise, but what it does is it has a record of probably like millions and millions of other clinical data. What illness was present, what were the symptoms, what were the medicines that were prescribed, and were there any counter effects to it? Did the patient get okay? Any other allied illness? It has a record of all of these things, and it is also now able to get onto the internet, the web. It's able to read medical journals, and it's able to assimilate these medical journals, right? So what is basically happening because of this is that a fresh engineer, I mean, a fresh doctor, someone who doesn't have all this kind of an experience, all they can do is, if they are able to enter their case history, their patient's case history into the clinical decision support system, then IBM Watson is able to tell you, okay, I am 80% sure that this particular medicine administered to this particular patient will not cause any problems, right? It will not say that, yes, it is. I mean, it is not going to replace a doctor, but for someone who doesn't have that experience, it basically supports your decisions. So you're looking at multiple symptoms, you're not able to figure out what the illness possibly could be. IBM Watson can help, because basically a machine learning algorithm all it does is it figures out some kind of a pattern between the data that you supply. That's what machine learning algorithms are good at. So if you have some 5-6 different unrelated symptoms and you're not able to make a diagnosis, then most probably like this CDS system might be able to like step in there and look out for patterns which you are not able to look at, and maybe like help you with it. Right. So as far as I'm concerned, 2014 and again 2017, two very important years, especially in medtech. The first one was because of IBM Watson, and second thing, what happened in 2017 was that the US FDA, they approved a deep learning algorithm. So a deep learning algorithm again is a machine learning algorithm, and they approved a cloud-based system so that basically what happens is anyone can collect your medical data, and you can run deep learning algorithms on it, and you could basically train your algorithms, and you could kind of use it for making some predictions. So these were the two important things which happened, and come 2020, it is just that we are just like unfortunate that COVID had to happen, and COVID just like kind of fastened things. But if we did not wait for it, right, if we were just going in the normal pace, I think another 5-6 years down the line, we would have again been looking at certain things, what new normal is kind of defining for us. So I'm not talking about the pandemic per se, but the way we are working, the way we are looking at learning, the way we are even looking at maybe like hospital consultations. 2 years back, we would not have even, in our wildest dreams thought of getting online and consulting with the doctor. But now something has forced us to do that. And we are finding that, for certain cases, it's actually proving to be good for us. Of course, there are a lot of challenges, but we are basically being pushed into the new normal, whether we like it or not. And we are kind of like, okay with it. Right. But what does new normal mean for us? I've been talking about machine learning algorithms, artificial intelligence, and if you are anyone who's just like me, then you should actually like feel a little threatened by it. So now I'm talking about clinical decision support systems by IBM Watson, which came out in 2014. Does that mean that humans would no longer find jobs? I would say, like, don't look at it that way. We should rather think of ways in which we would be able to leverage this technology. So in case of threat levels, if you ask me, an engineering job is at much more higher threat levels than doctors. Not that it's any consolation, but I think what we should basically look at is not feel threatened by what machine learning is bringing into the table. Rather, we should figure out ways in which we could leverage these technologies and probably do something more better, because no matter how advanced the artificial intelligence is, there are certain things that it cannot do. And if you notice the presentation, I've put it inside a big caps and yet, right? So it just means that we don't have access to, or we've not seen artificial intelligence that can do certain things. But until and otherwise it happens, humans still have an advantage. And that's what basically a lot of technocrats define as the 21st century skills, right? So if you look at 21st century skills here, these are not things, which you have to like kind of like memorize and hold in your head or something like that. So these are basically skill sets which a machine cannot possess, right? So a machine cannot have creativity. It can look for creative solutions, but creative per se is not going to be there. A machine cannot do critical thinking. A machine is not flexible. You program it to work in a certain way, that's how it's going to work. It doesn't have emotions. It doesn't have the tendency to inspire people. It doesn't have anything called as a social working or collaborative effort. Right. So basically look at 21st century skills, and all you'll have to do is, figure out how do you embrace this new technology. And this is basically what you need going into the new normal. Right. So according to me, what does new normal look like? I've spoken to you about the technology. I've spoken to you about how it has been accelerated by the pandemic. At least according to me, these three are some of the core areas where people should think of concentrating, which I feel would probably become the future, right? And also what I think is kind of relevant to this particular setting. So the setting in the sense I'm delivering this to academia, I'm delivering this to students. So basically from that perspective, these are the three very important probably aspects of the new normal, according to me. So the first one is remote working. So it is remote working / remote learning. So we need to kind of understand how we could still continue working, continue learning, continue teaching remotely, because whether we like it or not, the different perceptions, the different projections, they say that we might be looking at the new normal, this kind of a remote working for the next 2 years. Some people say 3 years, but we don't know for how long. But certain things, once you form a habit, once you get used to certain things, you've optimized your systems to certain means of working, it gets very difficult to go back. I mean, me personally, we used to be running about 1.52 lakh rupee bills in rentals and travel and things like that. But over the last 1 year, we have kind of learned to adapt to this. We no longer hold the office space. 100% of my workforce is working remotely, and we are still managing. I'm saying managing, we are not thriving, we are still managing, but we don't see any problems in this going forth. The second most important thing is the way in which the future of learning would look like. I'm not talking about academic learning, but this is also something where once you get onto the job, once you start looking at things from that perspective, what's going to work, right? So we have this new concept called as micro learning. So micro learning is where you learn in very small bits. You don't sit through a 1 hour lecture. A 1 hour lecture is broken down into 10 parts of 10 minutes or 10 parts of 15 minutes or something like that, right? So what you do is the focus is more on bite-sized learning. So again, I think you would probably be more, it would probably be more relevant for you to understand this as well. Human beings' attention span is usually supposed to be around 10 to 15 minutes. So you keep speaking about one single thing for more than 10 minutes, you're going to lose them. So which is also the reason why I have such a colorful in front of you, because I need to keep your attention span for the next 1 hour at least. So this basically something which has come up, and they don't kind of look at spending too much of a time learning something. They want to having very small learning materials, and they want to have a constant learning materials rather than taking a break from career, going for a certification 3 months, 6 months, and then coming back. I think this is on its way out. At least as far as engineering domain is concerned, it is on its way out. I would not be in a position to answer it from the medical perspective, but this is what is happening in the engineering perspective. They expect you to learn anytime, anywhere, from your mobile phone when you're traveling to office, and they want you to continuously keep learning. That's about micro learning. And finally, the last piece of aspect of the new normal is going to be technology leverage, right? So you cannot say that, hey, I'm from a medical background, I don't know technology, I don't know how to code, I don't know what you guys are talking about. I mean, you can no longer afford to say that. Maybe we could have done it earlier, but you know that these days the bare minimum tech skills you should have is maybe learning how to put a PPT together, learning how to present it, sharing your screen, sorting out network issues. I mean, you're already part of the technology circle, right? I mean, this was not something which you were doing earlier. The last time I probably started preparing PPTs and started doing this was when I started working with Pilani. So I had to take classes online. So I had to set up a mini studio at home. I had to look at all of those things, lighting among other things. But these days, as we start moving forward, this would become irreplaceable. So we would not be able to replace technology, right? And at this point, I just wanted to put this quote here, right? This is especially very true as far as the engineering industry is concerned. They don't care where you learned something or how you learned something, right? All that matters is what can you do with what you know. might sound a bit confusing, but you would have heard people like Elon Musk say that we hire people not because they are an MBA, but we hire them despite them being an MBA. Or they say that we don't look at your educational qualifications. You don't need to have a college degree as long as you know how to do coding. That's what Musk was saying. Sundar Pichai was saying as well. As long as you know how to do this, we're going to put you in. So of course, this does not hold good for you guys. But basically, what you need to understand is it doesn't matter if you learned your subjects sitting inside a classroom or if you learned the subject sitting inside a virtual classroom. All that matters is what can you do with what you know. Right now, this is something, I'm just a bit off topic here. I'm not talking about innovative tools, but these are all things which basically build up to what I'm getting at, right? So this is something which a lot of students have a huge mind block with. So they think that, we were supposed to be in campus, but we are stuck at home. How do you expect us to learn, right? I mean, a very valid question that quite a lot of you might have. I'm just trying to make things easy for you. So all I'm saying is, don't go in here with a closed mindset. Go in with an open mindset and basically start seeing things for what they are. So just because you're learning online does not mean that you don't get to learn the same things. All you'll have to do is maybe think about how you could basically make things better, right? So fixed mindset, growth mindset. I'm just putting it here. I'm just setting the stage. I think the next week you're going to have the same set of lectures being delivered by Dr. Sandhya. And when she's doing it, she would be talking about virtual learning from a behavioral perspective. So this is a behavioral aspect. You would probably be learning about it in the next week. But at least, from my side, what I'm trying to tell you is, don't go in there with a closed mindset. All you need to do is just make a little bit of incremental improvements. So what I'm trying to talk in terms of mathematics here is, you putting in 99% effort for 365 days, and you're putting 100% of your effort and just making a small incremental effort, a 1% more, and you see the difference in front of you, right? So it's almost like 100 times increase between doing a 99% and 100%, and about a 40 times between doing 100% and 101%, right? So that's basically me being an engineer and me trying to crack some engineering related jokes. But yes, so what I meant to tell you is, don't be threatened by technology. Even if you can't write algorithms today, all you'll have to do is take up a small coding class, learn how to use Python or learn how to use R, and trust me, the applications are huge, right? So just because you're doing your medicine degree does not mean that your career should necessarily end up as a doctor. Especially these days, there's a whole big domain called as medtech, where someone with a medical degree can actually be working on a technology side of things as well. So this is something from my side for you to be thinking about. So now let's leave the new normal aside. Let's get into the 21st century skills, and let's see what these skills exactly are, and why is this skills, why is it that you should need new kind of a tools to basically acquire these skill sets, right? So all we all heard of this thing where unless something is done, something is shown, we think that it cannot be done. So when Dr. Kotur was talking about the virtual learning and things like that, this is something which has been close to my heart. So right now, we think that we cannot learn using virtual tools. We cannot learn by Zoom meetings or WebEx meetings or something like that. But all I would say is, it is just that it has not been attempted. So we can still learn by just like watching YouTube videos, and it is very much possible to kind of evaluate you just by making you watch some videos. We kind of just need to start rethinking on how things could probably be, right? So of these 21st century skills which we spoke about earlier, I'm just going to take a couple of things here, and I'm just going to be trying to build my case based on that. the primary skill set which I'm going to be taking is critical thinking, right? I'm just going to be taking critical thinking as my primary base, and I'm just going to be talking based on that. Of course, critical thinking, creativity, and technology, they all go hand in hand. Productivity, flexibility, not so much, but we're just going to be talking about those things which directly affect this, right? So what exactly is critical thinking, and how does it basically affect us? So critical thinking is that aspect of human behavior where you are able to take some decisions based on numerous other inputs, right? So these could be directly be connected. It can be like something which is totally disparate. It is something which makes absolutely no sense, but you're able to assess a situation and you're able to take some kind of a decision based on that. So some examples could be something like this. You do know that machines, they do learn from huge amounts of data. So I spoke about IBM Watson, and IBM Watson, it has the ability to crunch, I don't know, maybe a database containing some 20 million data, and it's able to derive some information from that, right? That's why it is offered to you as a clinical decision support system, right? Please make a note of that. It is a decision support system, and it is not a decision system on its own, because what the machine still can't do is learn to think or learn to learn non-sequentially. So I'll just show you some examples of non-sequential learning, and we would also be able to take sometimes we would be able to take what we call as leaps of faith, right? We would be able to take leaps of faith, and we would be able to arrive at conclusions which the machines can't do. So machines can only think linearly. They don't have quantum thinking capability as of now. So they can only think linearly, and they can only arrive at conclusions statistically, which means IBM Watson can say, I'm 99% sure that this particular drug should cure this particular disease. But humans can actually like go something more than that, and it can say, though I don't have sufficient information to say that this is basically the cause. Maybe something like someone has fallen down and their hand is swollen. You don't have an X-ray yet, but you could maybe take a leap of faith and say that you might have a fracture. So if it's really swollen, yes, maybe a fracture. If it's slightly swollen, paining, maybe a hairline. You basically take some leaps of faith based on your experience and expertise as a medical practitioner, right? So these are some things which basically like comes in as critical thinking. So you doing certain analysis where the data is not explicitly given. So when we talk about leaps of faith, when we talk about critical thinking, there might be something about why is it that machines can't do maybe what we call as critical thinking, or why is it that you need a human to do a critical thinking, right? So now this is the problem which we very frequently is when we control an autonomous driving car. So how do we program the car to act in these or in each of the three situations, right? Do we look at the greater good? So here in the first case, I'm saying there are maybe like 9 pedestrians on the road. So is it better to kill one pedestrian than killing 9? Or in case one of them is on the road, is it better to go hit the median and kill the driver and the occupants? Or maybe the same thing if there are 9 people. So how do you basically like take these decisions, right? So these are some things which have not yet happened, and frequently as human beings we do take these decisions knowingly or unknowingly, and that basically is what we call as our critical thinking capabilities. So no one has taught us to kind of swerve and miss a pedestrian, right? But mentally what I would be doing is I would not go hit this guy, but maybe what I would do is I would try to like nudge my way into here, and I would probably take a risk that if I do nudge my way, this guy gets on top of the bonnet, he gets rolled over, he's not crushed, maybe both of us get to live, right? Or maybe in this case I have no choice but to maybe just go graze the median, try to like hit just 1 or 2 guys. There is something called as a self-preservation, and there are also things which kind of like allows us to take much more complex decisions which a machine would no longer be able to do, right? So that is your critical thinking skills. And when we think of these critical thinking skills, so the next question is, how do you develop these kind of critical thinking skills? Because I said critical thinking also goes hand in hand with your experience and expertise, right? So to do this, to kind of handle it, we have new educational solutions. We have what we call as learning games or serious games. And I'm just going to take a small detour here. And I've put up this, the link for you. You could take a screenshot, you could go back and you could maybe try it out on your own. I'm just going to stop my presentation here and I'm going to show you how this game looks, right? So one of the initial meetings we had with the Innovation Center, there was one problem area which was brought up. That's that the students are sitting at home, they don't have patient interaction. So how do they get to develop those kind of experience if they're not allowed to come to the college campus, meet the patients, work with them or something like that. So I think this should basically answer your question. So I'm just gonna take you through this. This is called as a serious game. It's a branching scenario. There's not exactly a medical kind of a game exactly, but it's something like where more of a social care worker, right? So this is the patient's case history. So you're going to visit a person who's a female, and she's a Russian, and she's basically like not approached for help, but the social worker is just trying to go visit them and trying to figure out if everything is okay, right? So this is online, right? This is online. So you see this for yourself. I don't know if you can hear the audio as well. Or if you can't, I think it should be okay.
Who is it? What do you want?
So now this is basically time for you to take a decision. So if you were to be in this particular person's spot, how do you basically handle yourselves? So I don't know, refer to arranged appointment. I think I'm going to decline annotation. Usually it messes up the screen. I'm sorry, I'm going to decline this. Yeah, I'm going to decline. Someone, okay, right. So now how do you do this? So do you express concern for the client or do you refer to arranged appointment? So I'm going to go with this. I don't know the answer, but I'm going to go with this, right? Let's see what happens.
I'm Ann Jones, a community nurse. I'm here for the appointment we arranged yesterday. Okay, please come in.
See, what happened was the moment you clicked on a decision there, the video branched off into a different branch and it went on over there, right? So if I were to choose a different decision, it would present a different scenario. But let's go with this. Let's see if this is the right one. Seems to be the right one. It's working. So they're just showing you.
As I said at the door, my name is Ann Jones. I'm a nurse who visits families in the community. We offer many services in this community for young families. You might be interested in these. Okay, would you like to sit down?
Looking at a sofa. You're looking at a coffee table, right? And the coffee table is next to a oven or something. There's a chair there. So now they're going to ask you to make a decision, right? So the client has asked you to sit down. So where are you going to go sit down, right? So these are the options for you. So maybe, I mean, I'm just showing you some examples here. So this is something where you get to make a critical thinking decision. So okay, I didn't make critical thinking decision here. I've played this earlier, so I know what to do. So I'm not going to remain standing. I'm not going to sit on the couch, basically because the couch is too much inside the house, whereas the table is close to the door. So this would probably like make it easy for me to get up and run away if something happens. I mean, this is how the whole scenario has been built. But
Let's sit at the table. Okay.
Right. So that was the right answer. If it was the wrong answer, they would have asked you to go back and redo the whole thing again.
Look at those bruises.
Who is she and what is she doing here?
Right. So the right answer again is to introduce yourself and move to the exit. But let me see if I can do something wrong, okay? Just to show how the branching happens.
I'm Anne. I'm a community nurse, and you have to watch your tone of voice. Get out!
See, it didn't exactly work that way because you ended up, maybe like getting the wrong side. So what would you do right now? Would you introduce yourself and remain sitting?
My name is Anne. I'm a community nurse.
What business?
Irina, I was sent by the hospital.
Right. So this is basically how the branching video works, right? So this is one way of how we could use technology to kind of like teach you new things, right? Let me get back to the presentation. I'll also share this maybe like this link as well. Hold on, yeah. This link as well, so that maybe you guys could try it out. We could basically build more of these things. So my idea here about talking about all of these things is also to kind of advocate you into maybe like, coming back to your innovation cell and starting to think of how you could maybe develop some kind of a scenarios like this, which we could basically use for teaching your first years and second year students, if you think that can happen. So I'm just giving you some examples here, right? So multiple agendas for me. I'm advocating you to start thinking like a technology person. So this, what you spoke about, is basically about developing your critical thinking. But what if I were to ask you to develop some creative skills, or maybe any skill for that matter, right? Skill is basically something you practice with your hands. You learn to do something and you understand something from that. So what if you were to do something like that, right? So this is where a second type of new age learning tool comes in, and this is called as a virtual laboratory. So virtual labs, they can be either animations or they could be digital replicas, right? So what I mean by digital replica is I could maybe build an animation of a heart, and I can show you that, see the heart is beating. You can go inside a heart, you can see. That's one way of doing it, that is animations. But I can actually build a replica of the heart and I can put it out there. So what's the difference between the two, you ask me? With a digital replica, I can maybe simulate what happens to the heart if you inject some medicines into it. I don't know, maybe if you were to start exercising, what happens to the heart? I can let you measure the rate at which the heartbeat, your blood pressure at different parts of the heart. I can let you measure how the blood pressure would change when the user is running on a treadmill, your blood pressure at a certain limit, and then you introduce some kind of a drugs into the system. So is it reducing your blood pressure? Is it increasing your blood pressure? So these are all things which we could attempt if you had a digital replica. So that's what we basically call as virtual labs. This again, for due diligence here, this is again something where ReynLab has been working on. We've been working on the technology side of things, not yet on the medical science, but I think they should still be good enough for you. I'm just gonna put the previous simulation into the chat message here, so you could just click on that link and go back and try to attempt doing that. We can of course create these scenarios as well. So now this is basically like a very simple simulation based virtual lab, right? So something to do with studying this tomato on a leaf. Again, not my cup of tea, but basically, you do have options to increase the magnification, this is basically where you have not been able to come to your campus, you're not been able to work with your lab equipment, but I can still like maybe, build some things like this and, digitize certain parts of your experiments. And we could also like let you do some kind of an experiment with it. So now you're supposed to count the number of stomata, number of epidermal cells, calculate what is called as a stomatal index, and submit. If it's right, you get graded for it. If it's wrong, you get done accordingly. So this is something which was developed by the government of India, and I think this is called as the OLab, online labs, right? So I'm just gonna share that link as well here with you guys. So a lot of food for your thought. Maybe, if you were thinking all this while that it was not possible for you to learn online, or if online learning would work only for engineering curriculum. I mean, some time back, people are thinking it works only for computer science and IT, but we've been successful in rolling out virtual labs for mechanical engineering and automotive engineering. And I think with all of your support, I think we can, kind of do similar things for the medical profession as well. In fact, one thing which might actually be very interesting for you is we have already been working on a similar kind of a branching scenario for a very close family friend of ours, who's the head of department at emergency medicine in a hospital here. So they basically wanted to train their nurses and hospital attendants on how to interact with people, especially during the pandemic times, because you do understand that people's emotions are at an all-time high. So one small word, a mismatch here or there, can actually flare up emotions, and people can actually get a bit aggressive. So we've been working on this kind of a branching scenario for them, where we basically build some cases and we offer it to them for training. So they basically get to understand how to deal with aggressive people. I mean, it's an important part, right? Whether it's a doctor or a ward boy or a nurse, if someone is extremely aggressive, then you should possess the necessary skills to basically cool them down and things like that. So again, these are the behavioral aspects of it, which, like I said, you would probably be looking at it moving forward. Great. So the primary objective of mine is done. I've shown you what virtual tools could possibly be. Maybe it's now started to give you some kind of an ideas, right? You saw those branching scenarios. You saw the virtual labs which we could do. You also do probably know about machine learning and artificial intelligence and things like that. So now I'm just gonna present a couple of more slides about what could possibly lead you to innovate or do something like that. So again, from my perspective, what I'm good at: education, edtech. So that's one thing which I see as a huge something having a huge scope in the medtech industry, because medical education is not accessible for everyone. We can probably offer education where we have infrastructure, but what do you do to offer this education maybe in Africa? We do know that it's one of the badly hit countries, and we don't have infrastructure. We don't have the finances necessary to build an infrastructure in those kind of rural areas, but we could still, not something which will replace traditional medical education, but at least something which can fill in as a stopgap arrangement. So that is something on the edtech side. Some examples, I've just put it out here. I'm not an expert in this, so this might be right, might be wrong, but I'm always open for discussions. So one thing I'm looking at very keenly looking at building is basically drug interaction sandboxes. So what I mean by that is, if you have a person who's probably has some pre-existing health condition, and it'll be possible virtually inject medicine, some drugs to them, and see how a combination of drug work on them. See, the basics behind it is fundamentally mathematics. So we know that this combination, this is what the end product is going to be, and this is basically going to cause some kind of a outcome, right? We know that. So we're just trying to see if we can build that as a virtual lab and offer it to colleges and young doctors as a means to perfect their skills. So for me, at least for me, I mean, you ask me what drug interaction you can study, I don't know. I'm blank at that, but I do know that if you take Mentos, you put some Coke into it, or you do something, it's going to release carbon dioxide. And that's probably not something you want to do, put Mentos in your mouth and drink Coke, right? So something on the similar lines where we can model the chemistry behind the drug interaction and present it from a medical perspective. Or we could have some interactive organ systems like what I spoke to you about, AR, VR enabled things where you would not only be able to observe how it's working, but you would also be able to introduce certain foreign elements into it. You could introduce a drug, you could introduce, I don't know, maybe a disease, I don't know, something like that. The next vertical I'm very, very, interested in is wearables. So non-invasive wearable technology, which I think is going to be the future as far as medtech goes, because of the amount of spending people do on defense applications primarily. So if you can come up with something which is going to, kind of measure the infection or monitor infections remotely, non-invasively, something which can be on the body, woven into your dress or something, and if it's something, something like, out of your Iron Man movies. I'm not saying to that extent, but there are still workarounds for doing it. Infection causes a rise in temperature. So if you're measuring the body temperature around, through a surgical bandage, which has got sensors in it, then basically I think you should have a way of measuring infection, or if the wound is actually getting infected and things like that. Finally, machine learning, quite a lot of applications. I'm not even scratch the surface here. I've just put something because the only things I've worked on is I've done a couple of CT scan processing, X-ray monitoring for COVID related things. When it came out 1 year back, we did some applications. So that's where I'm talking from. So end of the day, I mean, what I'm trying to tell you is these are possibly the innovations that you could think of in medtech, and this is just me trying to pull you into our world, right? Pull you from the medical domain into the technology domain. So maybe we could start working together. I'm just trying to tell you that there's a whole lot more for you guys in terms of careers than just the being on the medical practitioner side. And in case you want hard data, then this is basically what we have for the global medical devices market alone. You do know there's been quite a lot of competitions and other things which has been floated by the government of India. We had such a huge requirement for ventilators, and someone had to come up with a low-cost ventilator. This is going to be there, right? It's just going to get more and more serious. People are going to start looking at it. If you have an innovative idea, then nothing like that, right? And also some research areas where you could possibly start thinking of working with your innovation center. So devices, genomics, wellness, especially wellness, because if you can come up with some kind of a remote wellness monitoring solutions, it's very much in demand right now. And of course, quite a lot of would also be by Dr. Sandhya in the next week. But this is basically me giving you some kind of an ideas about where you could get creative, where you could come up with innovative solutions on these lines. So that brings us to the end of my presentation. I think this is the last slide. Yes, that is. So, no, I'm sorry. I went backward. Yep. So that's the end of my presentation. So open for any questions, any discussions. I'm just gonna minimize my screen so I can see your chat boxes, and we can take any questions if you have. Right, so let's put it out here. If there's any questions from your side.
No questions.
Great. Super. So
And no questions from any of the students or faculty. I think Sajeeth, you have explained it very beautifully, so they don't have any queries.
it's either that, ma'am, or I went too technical. That's always a fear I have. So one of the two things. So I hope it's the former one. It's that you were able to understand and you don't have questions, or maybe it's too new. It's too much for you to process at this point of a time. I can perfectly understand. This is my first time talking in front of a crowd like this. So my apologies if it went too technical, but I hope there was something which you could take away from this.
No, Sajith, we may take little time to process it most probably. That is the correct answer for this.
Thank you,
Mostly,
ma'am.
I don't think he have spoke so much technically. Very nicely you have taken step by step to us how it can be used in our medical field. So I don't think so. Any questions? No questions?
Yes, maybe they are thinking what needs to be done. See.
They are immersed with that.
So,
excuse me, sir. Am I audible?
Yes.
Yeah. This is Praveen, sir, from Department of Mechanical Engineering, AVIT, and also convener of IIC. It was a very wonderful presentation, and it was really interesting too. One of my questions is, you had said that anything can be simulated over the organs. So is it possible to have any new organ or anything? For example, if I want to print a vein, is it possible to simulate that also? What is the amount of CFD? Because we, as a mechanical engineering students and faculty, we used to know what is the CFD. What is CFD is nothing but the computational fluid dynamics. So is it possible to do that simulation even?
Sir, like you are able to simulate an aerofoil. You're probably able to simulate maybe some motors because you understand how it basically works. So you can write mathematical equations. You could probably go with your theorems. You have the equations to solve these the boundary conditions and things like that. But unfortunately, for the human brain, you cannot do that. We are trying to with respect to our neural networks and things, but like I said, unless we have understood what quantum mechanics is, we cannot possibly do the human brain. But I think the other things we can kind of get closer to it. So at least say the human heart, we know how it works. We know basically like we don't know what drives it, but if it works, it works. So which is why we've been able to have something like pacemakers. We have artificial organs and things like that for pretty much a lot of the human organs, except for maybe the human brain. So whatever we can mathematically model, if you can write an equation, if you can mathematically model it, then yes, you can build an artificial heart or an artificial lung. But if you don't understand how an organ works, if you cannot represent it using mathematics, you would not be able to even simulate one small bit of it. That is basically where we are stuck right now.
Yeah, thank you very much. Yeah.
No more questions.
So this is Dr. Ravi.
Yes, sir.
So in your last slide, we have seen some kind of machine learning or artificial intelligence towards genomics, right, sir?
Correct. Yes.
Since I am working in SMP, can you try to give some kind of advice or exploration towards that? So what kind of things I can take forward in
Sir,
terms
like
of...
I cannot talk about this from the medical perspective. So if you could come up with a problem from your perspective, I can probably tell you from a technology perspective how you could possibly approach it, because I'm not even remotely qualified to talk about the technology from the medical side of things. But if you were to ask me how do you solve this, maybe using some algorithms, then that part of it I can probably help you, sir. But otherwise, I'm sorry, that's not my. I mean, I have no expertise in that area.
Okay, thank you.
maybe the normal way the sequencing is done, how it's analyzed, probably you can make a machine learning with that.
Yes, sir. I mean, if you can show me how it is done currently, the data that you have, and if you can basically point me how you could make it more efficient. I mean, the domain side of the knowledge, if you can give me, I can help you develop machine learning algorithms, which platform you should use, which algorithm might be better than the other one, and things like that.
Okay, sir. Then I can send you the complete details about the. For example, if you take one gene, you will have a multiple SNP will be established there. So, so what we do is that we try to find out what type of SNP is been more popular in the particular populations. So if I can able to do the sequencing for a particular population, and then I can give the data so that you can able to find it out what type of SNP is more predominant in particular population. Is it possible, sir?
Sir, I would probably want to sit down with you more and understand, but this is something where the research is already happening. So I'm pretty sure within limits, if you are able to give us with the data, supply us with the data, then I think training it on one set and then deploying it on another set, that is the generic way in which we deploy these algorithms. So I think we should be able to do that.
Okay, okay, sir. So can you share your email, sir, email ID or a phone number so that it will be.
It's here. I mean, you can still see my screen, I presume. So it's sajeeth@reynlab.com.
Okay.
I've anyway shared a copy of this presentation in the chat box as well, so you could just click on it. It should take you to the Canva page. You should be able to see the presentation as well.
Okay, thanks.
Maybe we can proceed further.
Sibi?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So, Ms. Pragati?
Yes, sir. Yes, sir.
Yes, Pragati, you can take.
Thank you, sir, for your insightful words on machine learning and virtual learning. I seriously got to put time for learning more technologies. It was truly interesting, sir. Thank you. To continue with the program, I would like to invite Dr. Pushpa Kotur, ma'am, convener of IIC, to share her view in brief. Over to you, ma'am.
Thank you, Pragati. Sajeeth, you have really created some critical thinking, what you can say, sort of, you have promoted them to think about how they can think about their own problems and how they can put it into ideas and then go to you to develop some sort of creative skills in all these medical students. I am sure about that. And you took us from what are the interested areas relevant to medical domain, and you explained us how new normal can be handled with with the help of technology. Also, you said about something about 21st century skill sets, new age tools, which we will be utilizing, and how a new normal can be handled effectively. Right from you started our use of artificial intelligence right from 1980 and took over tour for how proof of concepts they turned into, I mean, cloud concept, and from there we turned towards framework, working with the frameworks which are already coded. Then that IBM Watson was really interested how they digitalized whole medical records, and they're sitting on a big, I mean, database, and which will help them they are already working on that with the clinical decision support system. But I think in future it will be still developing, And we can, of course, we cannot compare that with human brain, which is definitely taking decision making is definitely critical in human brains. So that's what you really showed us how evolution took place in the medical learning algorithm. And with virtual assistants, how we can improve our learning experiences. In fact, we used to watch surgeries and used to try to learn new surgeries. But now what has happened? Our postgraduates, they will download videos, they will watch what we are doing, and also from downloading videos also they will learn something, and then they will try to practice it when they are operating. So there is a lot of difference what our generation learned and now what they are learning. And how remote working is also helpful, even though for remote working, this virtual learning is also helpful. We have accepted this. Actually, in COVID pandemic, we have accepted this situation, and we are trying to improve ourselves with micro learning. Our students definitely can do well because we have whatever systems we have put it in the place. But only thing, virtual thing, I was actually thinking when my son used to play games, I used to say that how he can drive through those all obstacles, and I used to always wonder. So that's what actually we are doing in our medical field, to maybe for setting up some diagnostic labs or practicing the practical skills of the students. Maybe you may be doing in future. But that is what now I understand that exactly what it was when he was playing game. That time I was totally ignorant. So our medtech, what we are planning, I think we should move ahead with this medtech skills. Both engineers and doctors sit together and they should try to formulate such answers for these all problems with their technical skills and whatever they have learned through practice. And they can definitely develop creative skills in virtual labs. And already Sajeeth is working with some emergency hospital, emergency medicine in some hospital. So it's behavioral aspects or communication skill, all such things can be learned on just practicing this scenario. He was showing those different things, that what is best way to behave in that situation. So that was really nice, so that we can train ourselves for all such skills in the virtual labs. I think I was actually asking for Sajeeth regarding this normal deliveries or cesarean sections in our field. Now hardly students get to know or get to see because they are learning from remote places. So how he can help us? So if such virtual labor rooms, such virtual operation theaters are there, in fact, our postgraduates or our undergraduate students practice their skills going through those virtual operation theaters or going to those labor rooms. And you can create different situations like emergency situation where patient is bleeding, and how we teach it through drills, but now we can teach it through your virtual labor room, virtual operation theater. So that's how I think we are going to go ahead with all such concepts. And really nicely, you have cleared all those concepts very beautifully. So thank you, Sajeeth. Thank you very much. Hoping to work together.
Thank you, ma'am.
At least I'm really excited to hear all this, that something can happen for our students like this.
Thank you, ma'am. It's an honor, ma'am. Thank you.
Yeah.
Thank you, Sajeeth, for your wonderful articulation with respect to the new normal and new technologies to be learned by the medical students. Okay, I think hope some sort of a skill sets has to be improved with respect to students of
Yes, sir,
I
definitely.
think in near future we can able to get some sort of innovations happening in medical knowledge under your guidance.
Your voice is breaking, sir.
Dr. Kotu sir and Dr. Vishnupat and Madam can create a kind of transformation in the arena with our AVMC. Thank you, Sajeeth and management. Yeah, I am traveling, madam, from Aruvadi to Pandi. I am traveling now. So I am traveling now.
That's what I feel.
I'm entering now Pandi. I am on the traveling. I gone to university today morning, ma'am. That's it. Thank you.
Okay. Thank you, sir. Thank you.
Thank you.
Thank you, sir.
And I think
Yes.
our students can now start thinking about this medtech thing. Definitely, I think it has stimulated this sort of thinking process in our students.
So would be more than happy to assist if anyone is interested in exploring this.
Yes, sir. Thank you, madam, for the synopsis. I now request Dr. Vishnupat, sir, President of IIC, for the closing remark. Over to you, sir.
So, thank you very much, Dr. Sajeeth, for giving an impressive talk. And I am sure that it would have stimulated our young students. And I think your students would have understood that we have to put the brain together, from the engineering side with the medical side. So as medical students, you will be observing so many problems, but engineering people may not know exactly what you have, what the problems you have. So in your day-to-day observation, you should see the problem. You should develop a structure, what actually happens in the different patients, and give it to him. Then he will do the machine learning part of it. See, after the machine learning is done, the machine will work much better than our brain, and with no time. The sense we think a lot, we may have to refer books, we may have to learn from other things. But once the machine is taught, it will give the feedback almost immediately, isn't it? So, two things he was telling about the CT scan and X-ray pictures and machine learning. So some of you can work with them and develop, collect different X-rays and interpret clinicians, radiology, then give it to him. Then based on that, he will develop a machine system so that if you take a picture of an X-ray, then it will interpret and give the diagnosis. Similarly with the CT scan. So you can develop small things initially so that you will also learn how actually it should be done. So what my suggestion is that the students who are thinking of a problem, you take the concerned specialty teacher with you. Suppose it's a radio diagnosis, you take a radio diagnosis. Suppose it's an obstetric problem, you take somebody from obstetrics. So like that. And work together and make the problem and discuss with the Dr. Sajeeth. And of course, Dr. Manivannan is always there to guide us. And then we have to develop. And I am sure that you will get some ideas, and in the days to come, you will develop some innovative devices which will be useful to us. Thank you very much.
Sir, actually, we look at the scores what students learn actually earn. But our students should come beyond that earning scores. They should earn scores by innovating something which is useful to our community or society.
The students and the teachers have to work together because they will guide you how it should be moved forward. You should also think of the problem. Then after you get the problem in your mind, then you discuss with the people like Dr. Manivannan or Dr. Sajeeth, so that we'll work together and develop whatever has to be developed. Like he talked about genomics. So Dr. Ravi was telling about developing some equipment for that. But he says he does not know much about the genomics. So we have to tell what actually is the problem and what is happening. Based on that, they can develop the system.
Actually, some time back, Sajeeth was telling that there are some IIT interns who are going to be posted here. If we can collaborate with our students, medical students, it will be more, useful for both our student as well as those interns also. So something like that, our students can think some problems and collaborate with them.
Willing now regarding some interns for your BITS Pilani students on medical field, biology and mechanical students.
Yes, sir. Yes, sir. Yes.
Both Vishnu Bhatt sir as well as Kotur sir as well as madam is very much interested. Dr. Ravi Kumar is also there. And if you collaborate the students with our medical students, I think some sort of innovations has happened in the very near future. So
Sure, definitely.
Please listen to that. Okay.
Sure,
because
sir.
we want to have a long-term relationship with you, where we can do a lot of innovations both on medical as well as in engineering side also.
Sure, sir. Sure thing, sir.
If want to do some project work in relation to medical field, then they are welcome. We will put some students from our side also with them. So both will learn medical science.
Sure thing, sir. Definitely, sir.
Thank you, sir. Coming to end of the program, it's time to bid adieu, and I would call Mr. Dev Kumar Singh, second year MBBS, for the vote of thanks. Over to you, Dev.
Thank you, Ms. Pragati. Honorable dignitaries, distinguished guests, respected deans, sir, all HODs, and dear participants. On the behalf of Institutional Innovation Cell AVMC, its entire fraternity and organizing committee, I extend a hearty vote of thanks to all the delegates of the seminar for their presence and contribution to make this seminar exemplary. First and foremost, I would like to express my gratitude to our special guest, Mr.Sajeeth Kumar, founder and CEO of ReynLab, for taking out time from his busy schedule and enlightening us with his knowledge. Sir, thank you for inspiring and encouraging us with your words. On this special day, you are an exemplary person and we have to learn a lot from you. I'm grateful to Dr. G. Selvakumar and Professor L. Prabhu for joining us from the sister institution. We are looking forward to working with you. I extend my gratitude to our respected dean, sir, P.F. Kotur, for providing the immense support and valuable guidance program. Thank you, sir. I express my sincere thanks to Dr. Pushpa Kotur ma'am, Chairperson IIC, for their thought-provoking. I am further thankful to Dr. Vishnu Bhatt, sir, the Director of Medical Research, who has been very supportive and has provided a valuable contribution in making this occasion a successful one. I take this opportunity to especially express my deep regards and gratitude to the faculties and other organizing committee members who had worked very hard to ensure that this occasion become a memorable success. Last but not the least, I thanks to all the participants for being attentive and making this occasion a resounding success. Thank you.
Thank you, Mr. Dev Kumar Singh. To all these attendees of the session, I, on behalf of entire team IIC, thank you wholeheartedly. Dr. CB sir has an announcement to make.
Thank you, Ms. Pragati, Amrita. We sign off now until we meet next week with another innovative idea by Dr. Sandhya.
CB,
Yes,
1
ma'am.
minute.
Yes, ma'am.
Everyone has to put their videos
Yes,
on.
ma'am. Yes, ma'am.
So that we can take one snapshot.
Could I have all the participants with your videos on, please?
Please, all students should put their videos on. All students should put their videos on so that we can take snapshot.
Quickly.
Yeah.
He is sending the video to Prime Minister's office.
We have to have this attendance, no? Thank you.
Thank you.
Thank you, Sajid.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you.
Sajeeth.
Thank you,
Sir,
ma'am.
thank you.
Rest till the next week.
Okay.